Hello everyone, I am Deepesh. Let me try to show you today how to use principal component analysis to do some data mining on some complex high dimensional data. Today I would like to show you how to use GeoJSON data to do principal component analysis. I am trying to think that there is some relationship between the location of the earthquake and the magnitude of the earthquake. So here I see some magnitude of earthquake which happened, magnitude 5.1 at Pacific Atlantic Ridge, and this is the location of that coordinate location. So maybe there is some relationship between the earthquakes and its magnitude. So I want principal component analysis to let me cluster that data and find out some hidden information in it. So I am capturing all the magnitude of earthquakes and their latitude, longitude and altitude, and try to copy and put it in an input file. So I have copied all the earthquake magnitude and the coordinates from this file, and have this file is available at earthquake.usgs.gov, and you can copy this information and put it in a file. So I have copied and put it in a file. As you can see, the file contains 8 rows and 1, 2, 3, 4 columns. Now we will use R to do the analysis and find out what we can understand. Now, why principal component analysis? Principal component analysis is a method for linear dimension reduction. So when you have data in higher dimensions, say 5 or 10 dimensions, then we can reduce it to 2 dimensions, because higher dimensional data is difficult for humans to visualize and understand. So we use the maths and statistics to help us and reduce the dimension into 2 principal components, so and then plot it on a 2-dimensional plane. Let us try to copy the data. Okay, let's copy the data like this. Because there is no header and the data is separated by commas, we are copying the data in this way. Then let us see the data that we have copied just now. Okay, the data is copied. We will try to create a response area, which is the response. So we have copied the response. What is the response? Response is the magnitude of earthquakes that we recorded, and we'll try to copy the coordinates in another array. So okay, yeah, so we have actually separated them out into 2 different datasets. Now we'll do the principal component analysis on the prediction, on the predictors. After doing the principal component analysis on the predictors, we'd like to see the scores. The scores, if you notice, will be the reduced version of the original high dimensional data. Let us store the first 2 components. And let us try to bind them into another dataset. And then let us try to do a k-means clustering using 3 clusters. I have just chosen 3 clusters. You can choose more if you want. Let us see how the data has been clustered. Okay, data has been clustered already. Now let's try to plot it. Okay, now we can see that the data has been clustered in 3 separate clusters. Here we can see that there are 3 different colors that are given: black, red and green. We like to see the centers also. PCH8 is nothing but different types of points that we can use. Here I have chosen a center point that looks like a star. So this is how we can do a principal component analysis of a complex dataset and make it easy for us to visualize. Thank you very much.